Okay, last video for this first homework assignment. Again, curve has slope. Slope means derivative, so we're basically saying that f prime of x is equal to x squared minus x cubed. We want to find the specific function. We're going through the point 1/13/12. So let's get f of x. Our general solution, x squared becomes x cubed over 3, x to the third becomes x to the fourth over 4, plus c. We're going to plug 1 in for x, and our result will be 13/12. So 13 over 12 is equal to 1/3 minus 1/4 plus c. Fractions, we're looking at a common denominator here. Our common denominator will be 12, so 13 over 12 is equal to 4/12 minus 3/12 plus c. 4/12 minus 3/12 is 1/12, so we have c plus, I'm going to move over to the left here, c plus 1/12 is equal to 13/12. We subtract a 12th from both sides, so c is equal to 12 over 12, which is the same thing as 1. And if c is 1, then f of x will be x cubed over 3 minus x to the fourth over 4 plus 1. Alright, now we're doing the same thing except with particle motion. So we're given velocity and we're asked about position. Again, find our antiderivative. Alright, so x of t will be equal to the antiderivative of velocity. 6t squared will become 6t cubed over 3, or 2t cubed. 8t will become 8t squared over 2, or 4t squared. And then minus 3 becomes minus 3t. Of course, we need our plus c. We know that the position x is 9 when t is equal to 0. As I mentioned in class, this is our new best friend. 0 means that if we plug in 0, we get 9. So 9 is equal to 0 plus 0 minus 0 plus c. So c must be equal to 9. So therefore, x of t is equal to 2t cubed plus 4t squared minus 3t plus 9. We need to be careful, though. We are not done, because we're asked to find the position of the particle at time t equals 1. Well, now that we know that our entire specific position function, we can actually find the position at t equals 1. So by plugging in 1, we have 2 times 1 plus 4 times 1 minus 3 times 1 plus 9. 2 plus 4 is 6, minus 3 is 3, plus 9 is 12. Alright, and since number 17 was so much fun, number 18 is asking us to do everything all over again, but we just got to do it twice because we're starting with acceleration. Acceleration leads us to velocity. Velocity leads us to the ultimate goal of the position. So here we go. Acceleration is equal to 10 minus 6t. So velocity will be the antiderivative of 10 minus 6t, which is 10t minus 3t squared plus c. We know that the velocity is 5 when t is 1. Okay, so if we plug, we get 5 when t is 1. So 3 times 1 squared is 3. So 5 is equal to 10 minus 3 plus c, or 7 plus c. So we're going to subtract 7 from both sides. c is negative 2. Alright, so v of t will be 10t minus 3t squared minus 2. Now that we have v of t, we can then get our position. And so here we go. X of t, I guess technically, well, position is 8, y. I was moving along the y-axis. Yep, let's make this y of t. So y of t, just because we're moving along the y-axis, is going to be the antiderivative of 10t, which is going to be 5t squared, or 10t squared over 2, but we simplify to 5, minus 3t squared is going to become t cubed, minus 2 will become minus 2t, and then we need our plus c at the end. All right, and we know that when t is 1, y is 8. So 8 is equal to 5 times 1 minus 1 cubed minus 2 times 1 plus c. 5 minus 1 is 4, minus 2 more is 2. c plus 2 is equal to 8, so we subtract 2 from both sides, and c is 6. So y of t is equal to 5t squared minus t cubed minus 2t plus 6. And our charge is to find the particle of the position at time t equals 3. So y of 3 is going to be 5 times 3 squared, 9, minus t cubed, 3 cubed is 27, minus 2 times 3 plus 6. So those will wipe each other out. So we have 45 minus 27, which is 18.